All right, welcome to page 3 of lesson 4.1 on statistics for Math 1. And we're going to take a look at the last type of plot, and this is called a dot plot. And this is for numerical values that are small values. They're definitely discrete values. And here, you would probably put dots for each individual number as opposed to ranges of numbers. The histogram is for ranges. The dot plots are for very specific ones. So if we ask, like, how many siblings do people have? And so for this, I asked in one of my classes, how many siblings? And so I'm going to write that data down. 4, 7, 6, 100. Somebody said 100. And then 3, and then 13. So for this, we would want to... we're obviously going to take a look at how many times these occur, and we'll make a graph on a line. Notice there will not be a vertical axis like we did for frequency for the other one. So I'm going to start here at 0, and then just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That actually fits all of them but one number. So I'm going to just label all those, and we'll talk about what we're going to do with that 100. All right. So we're going to deal with 100 here in a minute. But with a dot plot, they call it dot plot for very obvious reasons. You just put dots for every instance that occurs. So the lowest value you have is 2. People said they had 2 siblings. I was actually one of those people. And I'm going to put a dot. That would represent me. And then somebody else in class had 2 siblings. And so we put a dot there as well to represent them. I'll cross those out since those are done. And then we'll go to 3 siblings. Well, 1, 2, 3 people said they had 3 siblings, so we just put 3 dots. So you can see how the dot plot is, it doesn't do ranges of values, it does very specific values. And so using a dot plot makes sense when you have very specific values like this that aren't over a large range. One person said they had 4. We have one person who said 6, and one person who said 7. One person had 10, and one person had 13. Now, what about this 100? Well, I could continue this and just put like a little break in the line and then put 100 here, and we'll put a dot there. So I can show that data, but obviously I can't go out to 100. This is a very kind of a rare situation where you get a value that is very far away from the rest. And so you have one option to show it like this. You could discard it from the data set. Sometimes they'll do, and we'll call that as an outlier. We'll actually talk about that later on in the lesson. And so what are other types of examples that we could use to represent this type of data? The number of books read. Like in a month or in a week or whatever time frame. As long as we don't go too long on the distance of time. Shoe size, right? So that's fairly limited, right? So we're probably not going to get anything like beyond 20 or something. So shoe size is a good one to represent with a dot plot, and then maybe the number of hours somebody studied for a test. Studied for like a specific test. Probably people might study, and I guess you don't necessarily have to do hours. You could do minutes. Well, minutes would be tough with this. I would say hours. And so you're probably not going to get 50 hours for a specific test, right? So your numbers will probably be somewhere between 0 to the 5 range, maybe 0 to the 10 range if you have somebody particularly dedicated. All right. So let's take a look at the next question here. So why can't we make a histogram for eye color? So go ahead and take a look at that and flip back to the previous page. Take a look at what the histogram was about, and then pause, go ahead and write your answer for it. Okay, so for this one, why can't we make a histogram for eye color? Histograms represent numerical data, right? So histograms represent, is that the word, represent? Not sure if that's the right word. I'd say visualize is probably a good word. So histograms help visualize numerical data. And eye color is categorical data. So it'd be better to use a bar graph for eye color because eye color is not numbers. All right. And now for the next part here, we're going to start talking about what we call measures of center. And so measures of center, we're going to talk about the mean, median, mode, and range. Now, mean is just another word for average. And to find the average, you add up all the numbers and divide by how many numbers there are. So add up all the numbers and divide by the number of numbers. And we do have a symbol that we use for that. And so X with a bar over it, this is a lot of times the variable that they will use to represent the mean or the average. So this is how we, and we talked about this in that mathematicians look for efficient ways to do things. So instead of having to write mean or average every time, they just said, okay, X bar, this is what we're going to put when we're talking about mean or average. We're just going to use X with a bar over it to mean that. All right, the next one is median, and the median is the middle number, just like a median in the road is in the middle of the road. So it's the median or middle number. And to find this, you have to put all the numbers in order and then select the middle number. So put the numbers in order. From smallest to largest. And choose the middle number. But what if there are two middle numbers? And this will happen if you have an even number of numbers total, you will wind up with two numbers. If there are two numbers, average them. So if there's two numbers in the middle, average them. If there are two numbers in the middle, average them. All right, the next one is called the mode, and this is the number that occurs the most often. It's the number that occurs the most often. And now this last one, this is not a measure of center. Mean, median, and mode are measures of center. Range is kind of outside of that. So I am including it here because usually when you talk about mean, median, and mode, usually range is part of that conversation, even though it is not a measure of center. And then the range is simply the difference between the min and the max. So it is the difference between the maximum value and the minimum value. And then we would just do max minus min. Those are usually abbreviations we use for that. All right, this completes page 3 of lesson 4.1. Please continue on to page 4.